It's arbitrarily, I forgot to start recording, don't I? What are people at home going to say? All right. It's arbitrarily decided, right? So I hand you a 35-degree angle, and I'm like, hey, I need the tangent of this. And you're like, okay. The first thing you do is you construct a right triangle with a 35-degree angle in it. And then you name the opposite side to that angle. No matter how you set it up. You name the opposite side O, right? So it's all constructed by you. And so you have full power over to do that. And then the question is, that always comes out to be the same answer, whether you construct a triangle or like someone else does? And the answer is yeah. We should kind of maybe think about why. So good geometry review here. And let's keep in mind, too, that if that process that I just described with Isabel, that only works if I hand you an angle like 35 degrees, right? What kind of angles doesn't this process work for?
Equilateral.
Well, I mean, this theta value, in order to put it into a right triangle, has to be what? Has to be less than 90 degrees. Like, you're good. If I give you like 88 degrees, you're like, perfect. 88 degrees, 90 degrees, some other angle, 2 degrees, and then you can proceed. But if I give you like 92 degrees and you're like trying to do this, it's not going to work, right? So we will extend the trig functions to handle. We'd like to be able to take this to all 6 trig functions of non-acute angles too. But for today, we're just going to do geometry review. All we know is acute angles right now. Yeah, exactly. That's what I mean. So this doesn't work. If I ask you like, what's the sine of 135 degrees, the first thing you do is put that into a right triangle. OH. Doesn't work, right? So the definition we're using today only works if theta is acute, which is why the title of the lesson is Trig of acute angles. All right, so here's a picture of a right triangle. I'm asking you about beta, this angle beta. I'd like the value of all 6 trig functions. And right away, you might see a little bit of an issue, right? In the end, it's going to be in terms of x, too, isn't it? Now, what's the issue? I already know maybe one trig function just by looking at this right away. But I'm going to need, in the process as we move forward, I'm going to need something else. What am I going to need? I'm going to need this side somewhere in there, right? I've got a name for this side. It's 3. I've got a name for this side. It's x. Tell me about this side that's missing.
You could name it x squared minus 3 squared.
You could use the Pythagorean theorem, right? So what does that come out to be, the Pythagorean theorem? What is it?
X squared minus 9. X squared minus 9.
Yeah, it's the square root of
X squared.
this pen is just broke on me. X squared minus 9 under the square root. Good. All right, now we have a name for all the sides. I think we can proceed. Someone gives me the cosine. I mean, you can. There are 6 trig functions. You pick one to tell me when I come to you. So, Bavesh, give me one of them. Any trig function of beta. You want to give me the cosine of beta? Sine of beta? 3 over x is the sine. I like it. And Rafi, you want to give me another one? Is 3 over square root of x squared minus 9. And Cam, you want to give me another one?
The cosine would be square root of x squared minus 9 over x.
Okay. And Eric, you want to do one?
The cosecant of the x
It would be what? X over 3. And Tammy, you got one? Okay, and then there's one more to get, secant. How about Tammy? What's the secant?
It's x over x squared, 3x squared minus 9.
All right, do you agree with all those? Good. See how that works? Isn't that great? And then someone might come along and tell you, oh, by the way, x is 10. In which case, perfect, the sine is 3/10. Perfect. The tangent is 3 over the square root of 100 minus 9, 91. Yeah, square root of 91. 3 over the square root of 91 is the tangent. We could come through and, someone could come through and say, x is 5. Wouldn't that be fun?
Yeah. 3, 4, 5, 9.
Ah, yeah, okay. Wouldn't that be fun? All right. All right, here's a picture. I'm asking right now for the cosine of 45 degrees is what we're going to figure out in a second, and I actually like an answer. And some of you already know that off the top of your head. But here's the process we want to use today. We want to think, okay, according to the definitions we use, we define the cosine today, at least, the cosine of 45 degrees as being, that's an acute angle. Put it in a right triangle. So pretend I didn't even give you this picture. If I didn't give you this picture, you would still draw this picture, right? Because that's the definition. Cosine of 45 degrees. Okay, what do? I draw a right triangle. I put 45 degrees in, today at least. And then I think about what the cosine of that angle is. Okay, so I know some of you already know the answer. You're already I already wrote it down because I'm smart. How? Why do you know it? Can you figure it out? Can you derive it with me? I'm like a baby geometry student. Don't tell me. Leave me. Go.
Well, because of there's the acute angle that's depicted is 45 degrees.
Okay.
And then there's also a right angle depicted.
Okay.
So that means the other angle must also be 45 degrees.
Okay, I'm with you, I think.
And
Even though I'm a baby geometry student, I think I'm following. Because 180. Yeah, I got you. Okay. Keep going
the
out.
inverse of the
Inverse, I don't know what that word is.
well, basically because the two angles are equal, the opposite sides must also be equal.
All right.
So, which means that the ratio has to be root 2, and 2.
Whoa, wait, whoa.
Whoa.
I'm a baby geometry student. I don't know where that all came from. Leave me there. Judah, help us out.
If we say that the hypotenuse is any x,
Okay.
right?
You want to call it something?
Call it x.
All right.
We know that x is going to equal a. So by the Pythagorean theorem, we know that x equals a squared plus a squared,
Oh, is this A?
or whatever that.
All right, this is
doesn't
A.
matter.
I'm with you. And this is A?
Right.
Okay, all right.
So a squared plus a squared equals x squared.
Okay, I'm using your letters and I'm following your rules here. Okay. All right, because of the Pythagorean theorem. I got you. All right.
That's going to a.
Yeah.
And then it's 2a squared equals x squared.
Okay. I mean, I don't know. I'm just hearing you. I'm just listening and responding. That's all I'm doing.
Oh, and then it's divided by 2.
Okay.
So x squared over 2.
All right. So this is the square root of x squared over 2. Is the name of this side. Awesome. So, all right. The cosine of 45 degrees is what? Does that help us? I don't know.
Yeah.
So,
It's
gonna be-
So we can say x is 1. Yeah.
oh wait.
X is 1, and then it's the square root of 1 squared is the square root of 2.
All right, wait, hold up. So, the cosine of the angle is, I think I remember, it's this side over this side. All right, so the square root of, oh wait. By the way, could we, some of you may be dying to do this. What is this equal to? X over root 2. Okay. So, if we do x over root 2 divided by x, we get what? This divided by this, right? I think I If you cancel out the x's, you get 1 over root 2. Okay, all right, I think I'm with you. 1 over root 2, do you guys agree?
Yep.
Yeah, in the end, if you wanted, like, Judo, you want to say what you were just saying? If you wanted, you could arbitrarily
You can just say
call,
x is 1.
you could just call x 1 if you wanted. This is going to be fun. Wasn't that fun? Okay. Did I do it?
Yeah.
All right, there we go. All right, so now I think I'm clear. This is supposed to be a 1, 2. Yeah. All right, so now if we arbitrarily call this 1, we get the same answers whether we call that 1 or 100, right? It doesn't matter. The x's cancel out here, we just saw. So whatever, 1 over root 2 sine. So that's a good reminder of how this came about in our lives. And then the sine is same thing. Okay, I see that, I think. Okay. Tangent is
1. Because if you, since cosine and sine, you take the length of one side of a over a.
yeah, we have here, let me just clean this up a little bit for viewers at home here. Yeah, I think this thing divided by this thing is 1. Yeah, you're right. This is the same thing. Secant is what? Root 2. Cosecant is root 2. And then don't tell me cotangent. You ruined it for me. Okay. Is 1. All right, good. Yeah, Rachel.
Do you care if we use 1 over root 2 or root 2 over 2?
No, whatever strikes your fancy, Rachel. It's up to you. Yeah. I mean, but it depends on who's the boss, I guess. I don't know.
He's our boss, so it's all good.
I mean, I don't. If someone claims that root 2 over 2 is simpler than 1 over root 2, then like I don't know what to tell you because I don't feel like that's true. I don't know. Now I will say if you said this is root 2 over 2, full credit. But it does make you look a little silly when you go down here and you're like 2 over root 2. Because that's just root 2, right? I think this is better. I don't know. Whatever you strikes your fancy. Okay. Let's think about 60 degrees here too. So how do we come up with this trig function? I'd love to evaluate the cosine of 60 degrees.
We do the same thing in arbitrarily say the hypotenuse.
We can arbitrarily say this is 1, that's great, but then what?
36.
I mean, some of you are already like, oh, I already know the answer.
One of them's
No, maybe it's just because you memorized it.
30, 60, 90.
How do we get?
It's like a unit.
Oh, I hear some people saying this is 30 degrees.
Oh, yeah.
I think I agree with that. Does that help though?
Yes. No, it's a 36.
True, but how does that help me figure out what the sides are? I know the Pythagorean theorem too. If I could just get one side, that'd be good.
Short side 1.
It's like 2.
Sure. It's arbitrary, like you said, so you can do whatever you want, huh?
The short one half the hypotenuse.
Why?
I don't remember. But whenever that.
It just is? Yeah.
One of them is like
The ratio of angle degrees to side length has to be equal for all.
Why? Why? What goes here? What goes here? I don't know.
Wait, 90 over 1 has to equal 60 over whatever that length is. They're opposite.
Green. So that's like true in any right triangle. Why isn't that true in the last one? 45
what the heck
is half of. Why would it be 1/2 then? On the last one.
Oh, and then one of them's like 3.
So this is 1/2 because why? Because it's half of. Why?
No, it's 2x and 3x and 2x.
But that's what I'm saying. That didn't work on a 44, 45, 45, 90 triangle, right? Even though that was because of the same. Has no one ever showed you this before?
Oh.
Has no one ever showed you this before?
You have seen this.
What are you looking at, friends? So this angle bisector right here happens to be in an equilateral triangle, happens also to be a median. That makes this and this congruent. So if all the sides of the equilateral triangle are 1, then that makes this 1/2. All right, is that a good argument?
Yes.
Okay.
And then the other one's root 3, right?
And then the other one you can get using the Pythagorean theorem. Okay. And it comes out to be root 3 over 2. All right. So 1 is a really convenient choice for the hypotenuse, isn't it? So the cosine is 1/2. The sine is root 3 over 2 divided by 1, right? The tangent is root 3 over 2 divided by 1/2. What does that come out to? This divided by this is root 3. Secant, now we're just taking the reciprocal of all of those. 2 over root 3, 1 over root 3. All right, so I just want to refresh your memory about not just those answers, but also where they came from. And I'd love to throw one more problem at you here before we leave. All right, so this has been good so far. One thing that might be lurking in your mind, if you could just be quiet for the last 2 minutes, that'd be great. One thing that might be lurking in your mind is like, okay, it seems really true that like anytime I know the cosine, I know the secant automatically. And anytime I know the sine, I know the cosine. And anytime, maybe I could like travel more lightly. Maybe I don't need all these trig functions in my backpack. And the answer is, like, you're right. And this problem is for you, friend. If I know the cosecant of my angle, can you get the other 5? Go. Right? Like that's what this is saying. Alpha is our name of our angle, apparently. So let's throw alpha into a right triangle. Can you label some sides? Any way you like. We've already had the conversation today that the labeling is somewhat arbitrary. So give me any labeling that makes the cosecant 7/4. Yeah, you could maybe, their first thought is sine is 4/7, right?
So that means that side, the opposite side is 4.
Yeah, so 4 and 7, does that work? You can also do 40 and 70 if you want, but let's just keep it that simple. Or 4/7 and 1, if you like, right? And then what's this side? It's not nice, is it? Yeah, square root of 49 minus 16.
Oh, no, I know.
All right, so I got the sine, I got the cosecant. What else do you want to tell me? How about the cosine?
So that means the cosine.
How about the tangent?
The cosine
the
is
cotangent.
root 33 over 7.
How about the secant? So the cosine is
root 33 over 7.
root 33 over 7. And while we're at it, the secant is 7 over root 33.
Yeah. And
Tangent is 4 over root 33, and cotangent is root 33 over 4. All right, and then the bell's going to ring soon, but I want you to think about this guy down here too. If you had gamma, could you do it in terms of x? Can we label the side?
well, it's ugly because then how do you break x into? Oh, wait a minute. Oh, wait.
All right, and then go do the rest, right?